Welcome to our channel. Watch the video until the end, give us a like, and subscribe to the channel to support us.
There are many strange phenomena and mysterious places in the universe.
NASA has found a place in the universe where there is nothing.
It seems absurd because nothingness doesn't actually exist. These places are so devoid of matter that they are truly frightening.
Many questions arise. Why has matter disappeared in these places? Or why have these places been able to grow to such remarkable sizes? For over 30 years, scientists have been wondering what is really happening in these mysterious locations.
And now, for the first time, they have found a completely new answer to this question.
The answer is both fascinating and terrifying.
Deep in the cosmos, researchers have discovered enormous stellar deserts. Where the light of millions of galaxies and countless stars would otherwise shine, there is nothing but darkness and emptiness. These mysterious space-time anomalies not only stand out strangely from the rest of the cosmic environment but also seem to rise above known physical laws and perhaps represent a completely new phenomenon. Due to the conspicuous absence of matter, these gigantic cosmic deserts contradict the usual predictions of Einstein's relativity equations and raise questions about the uniform structures of the cosmos. Above all, the sizes of these fields where there seems to be nothing contradict a general rule of cosmology. But their sizes not only break our physical rules but also quickly push the imagination to its limits. These possible holes in the fabric of space-time are gigantic in size, spanning millions of light-years, a size comparable to the largest known galaxy clusters. By comparison, a single beam of light, traveling nearly 300,000 kilometers per second, would take thousands of years to cross one of these enormous empty fields. These regions are so vast that they could surpass in scale some of the largest structures in the known universe, such as the Virgo cluster or even the Laniakea supercluster. They represent a mysterious absence because, imagine galaxy clusters like Virgo, which contain several million galaxies, while there is almost no matter in the collections of spectral nothingness. But the frightening thing is that these areas are not completely empty. Researchers have found single galaxies that exist as lonely and desolate spots of light in the middle of an endless desert and wasteland. The existence of these galaxies makes the voids in the universe even more unsettling.
We are faced with a cosmological puzzle that could radically change science and our view of the known universe. What causes these vast empty areas in the fabric of space? Are they the product of natural cosmological processes, or could they indicate phenomena that we have not yet fully understood? Bigger, the voids.
The structures that cause so much concern to scientists are gigantic cosmic voids, empty spaces of such epic proportions that they cannot be there by chance. They must have a special function or are the consequence of incredibly brutal processes in the cosmos. The gigantic empty spaces between galaxies and galaxy clusters are one of the most puzzling phenomena in the currently known universe.
Even black holes are better studied than voids.
A particularly notable example of these structures is the void that NASA has described as a gigantic void of millions of light-years and almost completely devoid of visible matter. This void was first discovered in 1981 by an astronomer named Robert Kirshner and is one of the largest known voids. This mysterious void extends about 330 million light-years. At the time, Kirshner and his team called their discovery the Great Nothing. Astronomers thought they had stumbled upon a unique anomaly. They didn't know that this void was not the only one. Today, many such voids are known, and some are even larger than the Boötes void, such as the Eridanus void, which extends over 500 million light-years, and the Northern Local Supervoid, which also reaches impressive sizes. In total, there are thousands of these voids that together make up a significant part of the universe. Dark matter and dark energy form voids. When we talk about voids, darkness, and nothingness in the universe, terms like black hole, dark matter, or dark energy automatically resonate, and it is fascinating to wonder if and to what extent these phenomena are connected. In fact, some theories suggest that the size and distribution of voids could provide us with profound insights into the nature of dark energy. It is thought that dark energy is responsible for the accelerated expansion of the universe, but it could also be mysteriously involved in the formation of these voids. From particle physics, we know that where there is no visible matter, there is not necessarily nothing. There are most likely invisible forms of matter that we cannot see simply because they do not emit light. In regions like the voids, unknown forms of dark matter could be more present than in other areas of the universe.
For this reason alone, these structures are highly sought-after objects of study.
To make the dimensions of the void more tangible, let's imagine the known universe as a soccer field. The galaxies and galaxy clusters would represent small spots and clusters on this field, while the voids would occupy most of the area. The galaxy clusters and superclusters represent perhaps 10–20% of the universe's mass, while the voids and the spaces in between make up the rest. This reminds us that scientists claim the universe is composed of about 85% dark matter, so these empty spaces and their distribution are ultimately mirrors showing the distribution of matter in the universe on a large scale, and the voids can help us understand effects such as gravity and dark energy.
Voids allow astronomers to study the effects of gravity in an environment devoid of the direct presence of large amounts of visible matter. However, gravitational effects within and around the voids are revealed only through the movements of visible matter, that is, the few galaxies within these voids. Other gravitational effects become evident when we study the light of objects located behind the voids. No matter how large a void is, it eventually ends in space, and if there are galaxies behind the void, their light penetrates through the void to us. These observations can provide information on how gravitational forces act over long distances and with little visible matter, allowing conclusions to be drawn about the distribution and properties of dark matter in the void. Voids are also ideal for studying their shape and thus the rate of expansion of these enormous empty spaces, which in turn allows conclusions to be drawn about dark energy. Scientists are studying the geometry and dynamics of voids in great detail. A universe with only one galaxy? Imagine that our galaxy is located within the Boötes void. Then, let's go back in time when astronomers first realized that our Earth is a planet within a galaxy. It was astronomer Edwin Hubble who first realized in the 1920s that there were multiple galaxies in the universe. Hubble first saw the Andromeda Nebula and other similar objects in 1923. Shortly after, Hubble managed to prove that these nebulae were independent galaxies outside our Milky Way. This discovery was obviously phenomenal, and you can imagine how it changed the cosmological understanding of the time. Since then, the universe has become increasingly larger. Today we know about 2,000 billion galaxies and look over 45 billion light-years in every direction with high-performance telescopes. If Hubble had lived within a galaxy in the void, he would not have been able to discover another galaxy during his lifetime. He would have seen only blackness and could have thought that the universe, outside a cluster of stars, was a vast nothingness. Only in the 1960s was our technology advanced enough to allow us to see as far as a scientist in the void would have to see to spot the first galaxy outside his own. An imaginary scientist within the void would think, from his point of view, that the universe is sparsely populated. In the 1980s, he might have come across the first galaxy cluster and been surprised to publish in a scientific journal that mysterious galaxy clusters exist in the universe for which the science of his world has no explanation. For us, the picture is exactly the opposite. We humans started by studying our world, which for a long time was the center of the cosmos for us. Then we observed the sun and the other planets. Eventually, we realized that all the stars are other suns and that there could also be planets there. Our science has grown linearly relative to our point of view, and new, initially inexplicable discoveries have provided us with new clues about what the world and the universe are really like. The voids show us that our view of the universe is still very one-sided and that what we consider normal may be the exception elsewhere. Brutal collisions of universes? It sounds absurd, but there is evidence to suggest that voids did not exist from the beginning of our universe but were created later through collisions so violent that the very idea of the forces involved challenges the limits of our minds. Calculations of certain points of the void have shown that two universes could theoretically have collided at these points. This means that voids are created where parallel worlds have collided. When two black holes merge, enormous forces are already at play, as are when stars explode or galaxies merge. But can you imagine the forces unleashed when entire universes collide? This theory has not yet received the recognition it perhaps deserves, as many conservative scientists do not like the idea of additional universes or the multiverse. However, the voids could be the first important clues. Traditional scientists explain the existence of voids with the gravitational interaction of matter.
Matter becomes extremely dense in some regions, and elsewhere, empty zones are created. In some known voids, remarkable structures resembling geometric cylinders have been discovered. These areas indicate that even in regions that seem devoid of matter at first glance, ordered structures can exist under certain circumstances.
These cylindrical zones within the voids are usually interpreted as the result of mergers of smaller voids. Large voids could therefore have formed over billions of years from many smaller voids.
However, this still does not explain the mystery of what these voids really are and why there is almost no matter within them. Subscribe to the channel now to never miss a new video.